Good day everyone. Today we're going to solve an example about the chapter 11 of thermodynamics, the combined conduction and convection. A 50 cm long, 800 watts electric resistant heating element with diameter of 0.5 cm and a surface temperature of 120 degrees Celsius is immersed in 60 kg of water initially at 20 degrees Celsius. Determine how long it will take for this heater to raise the water temperature to 80 degrees Celsius. Also, determine the convection heat transfer coefficient at the beginning at the end of the heating process. So we have here our figure in the left area. Now list down all the given value of our problem. We have here the mass of 60 kg, the temperature 1 that is equal to 20 degrees Celsius, and the temperature 2 that is equal to 80 degrees Celsius. And also we have here the Q dot is equal to E dot generated, or the energy generated, that is equal to 800 watts. So now our task is to find the enthalpy 1 and the enthalpy 2. But first thing we do is going to look the property table, table A2, that is C is equal to 4.18 kilojoules all over kilogram degrees Celsius. And now the first task is to find the change of time, because it is we're going to determine how long. So by deriving all the formula in the upper part, we can get the change of time is equal to mass times the specific heat of the water, quantity of T sub 2 minus T sub 1 all over the specific heat input. So plugging all the value, we have here 60 kg, that is our mass, and 4,180 joules per kilogram degree Celsius, that is our specific heat of the water, and also 80, that is our T sub 2, minus 20, that is our T sub 1 degree Celsius. So we have here 800 joules per second, that is our specific heat input, and by plugging all the calculator, we can get 18,810 seconds, and by converting that into hour, we have here 5.225 hours. And now for our surface area, we have here the formula of pi times diameter quantity L. So we have here the pi times 0.005 meter, that is our diameter, times the length, that is 0.5 meter, and we can get our surface area is equal to 0.00785 square meter. And now, since we are tasked to determine the convection heat transfer coefficient at the beginning and at the end of the heating process, that is denoted to H sub 1 and H sub 2. So we have here the formula of specific heat is equal to heat times the area, and also the quantity of temperature 1 minus the temperature 2. And by deriving that equation, we can get the equation for the height, that is equal to specific heat all over area times the change of temperature, that is T sub 1 minus T sub 2. So now it is going to plug all the given value to our calculator, and we can get that H sub 1 is equal to 1020 watts per square meter degree Celsius, and also the H sub 2 is we can get 2550 watts per square meter degree Celsius, and that is our final answer. Thank you so much everyone, and see you on my next video.